And what we'd like to talk to you about today is our approach about virtual reality, but also augmented reality, because there's a lot of overlaps. And in particular, what we are interested in is how you can use these technologies in order to interact with open data. Because for my own background as well, many years ago, I was working with robotics, but I was mostly interested in the interaction aspects. And it wasn't only about robotics, it was about all parts of technology. How do users actually interact with the technology? How do they make use of the technology? So we're interested in all these new things, but not for the sake of, let's say, purely the technical aspects, but how are these become part of our lives, how we can interact them in meaningful and constructive and kind of creative ways. So I'll give over to my...
Yeah, so... Okay, perfect. So yeah, as Aris already said, so my name is Nico. I'm also a researcher at the Media Technology Department at Linnaeus University. I finished my master's degree there last September. So prior to that, I studied media technology, international media and computing at the HTW in Berlin, in Germany. So that's also where I'm originally from. So, and what we are going to present to you is as Aris already said, our approach of interacting with open data in virtual reality. So, and for me it is particularly interesting because it was, so what we are going to present to you as well is the outcomes of my master thesis project. So, and hopefully we are going to continue with that in the future for our research efforts. So what we are going to talk to you about today is a little bit, we give you an introduction to virtual reality. So therefore we introduce you to the concepts of augmented and virtual reality. So you have an understanding of what we are talking about, and we are all on the same page. So then we are going to talk a little bit about the terminology of immersion and presence, as those are two very interesting concepts and very important concepts to understand when talking about virtual reality. So, and then we talk a little bit about virtual reality in more detail, giving you also some use cases where it has been applied recently. So afterwards, we are going to present to you our ongoing research efforts regarding the interaction of open data, or interaction with open data and virtual reality. So, and after that, we are also going to talk a little bit about how to interact with open data in augmented reality.
And one thing I forgot to mention is that we're trying to keep the talk very casual, and so feel free to interact and raise questions even in the middle of things. I'm going to be interrupting Nico a lot myself, so you should feel okay with doing it as well. So that was the first interruption.
Yeah. Perfect. Yeah, just do as he said. So I mean, we keep it very open, and if you have questions, just interrupt me right away. So yeah, so let's talk a little bit about virtual reality in general and about augmented reality. So, and what is augmented reality? So with augmented reality, so we mean we're extending the real physical world by adding digital information. So we still have, okay, so you probably can't see it, so but there are two people here. So and they are playing with this sandbox, so and they are forming and playing within a normal sandbox. So but on top of that we also have a projector that is getting the depth information, so and projecting this kind of digital overlay on top of the sandbox. So we have this typical concept of, okay, we still have real-world objects and real-world our real-world environment. So, but on top of that, we also add digital information somehow. So, and for virtual reality, so we create a truly virtual world. So, a differentiation between is what is real and what is not is often very difficult. So, simply because we take away that real-world physical environment, so and go fully into the virtual one. Right, so, and talking about immersion and presence. So, those are, as I said, in the beginning, two very important concepts to understand when talking about virtual reality. So, we have immersion on the one hand. So, it's cited or defined by Bowman as immersion refers to the objective level of sensory fidelity a VR system provides. So, that technically means immersion is provided by all the technologies that you are going to use in order to experience virtual reality. So, for example, you have like a head-mounted display, you might have like a controller or other motion tracking sensors and systems. So, and all these technology systems, they provide this level of immersion, so to say. So, and when we talk about presence, presence refers to the user's subjective psychological response to a VR system. A user feels like being in the virtual world. So, as I said, like immersion is kind of like the all the technologies that take together that you feel like you are like in the virtual world. So, but presence is like particularly the feeling, your human feeling of, okay, I am actually in this virtual world. So I'm not in my normal office environment anymore. So, but I'm underwater or I'm in space. So you actually feel like you are there. Right? So, and there are like different virtual reality technologies out there. So we are showing you two today. So there's one thing that is called like a cave automated virtual environment. So, and the idea of a cave is you are physically standing in a cube-like environment with different walls all around you. So, and we have like projector technologies as we are using here that is projecting the display, so to say, onto the walls. So, and you are usually wearing nowadays some stereoscopic 3D glasses, as you probably are familiar from it from recent cinema experiences. So you have, first of all, a feeling of a 3D effect. So, and you can very naturally walk around in this very limited cube-like environment while being presented with the content like on top of the walls. So, and as opposite, therefore, we have the head-mounted display. So the user is also wearing some kind of glasses. So, but the glasses are usually a little bit like heavier. So, and have like, as the name indicates, like a display attached in front of it. So, and these glasses shut you off your physical environment like completely. So you are not able to see your physical surroundings anymore. So because you are like completely confronted with the display in front of your head and in front of your eyes. So, and by naturally like looking around, so you will also, the view inside the virtual environment will also change accordingly. And this is usually therefore to give you a very natural feeling of experiencing digital content. So yeah, going a little bit back into the history, the very first VR or AR head-mounted display was developed by Evan Sutherland. So it was called the Sword of Damocles. And yeah, it was back in 1968. So, and it was a very, yeah, very simple yeah, head-mounted display. So you had like some optical lenses in front of here. So, and back in the days, of course, the graphic capabilities were also not that high evolved as it is now. So therefore, they were simply able to have simple wireframe polygon structures like floating in the air in front of you, and yeah, you could see these wireframes through these optical lenses. So, and the interesting thing here is also the head tracking was completely mechanical. So, as you can see here, so the user were wearing this like head-mounted display. So, and you had a like a mechanical structure attached to the ceiling. Thank you. Attached to the ceiling, so which would traverse the head movement kind of like accordingly. So yeah, nowadays head-mounted display looks like very different. So here we have some of the Oculus Rift models. I'm sure you have heard about the Oculus Rift. Yeah. So it was like a very successful Kickstarter campaign a couple of years ago, and so basically VR has never been really away from the research, so but it was like away from the mainstream, so to say. So because no one was like really touching it, because yeah, VR technologies were usually quite expensive and not as affordable for like smaller development teams. So, but now with the tremendous success of the Kickstarter campaign from Oculus, yeah, VR became affordable again, so to say, and yeah, it's so much like affordable and also very attractive for young, small, like indie development teams.
I mean, as you have seen from the historical examples, the early systems were very cumbersome. They were very heavy. There was a lot of wires everywhere. I mean, obviously, it wasn't aimed for like the consumer market, but also, I mean, there were limitations from the technology back then in terms of the response speed of the visual input, and that was very important because, of course, you had a kind of virtual reality experience. But let's say the sense of disbelief that you had to put, the psychological effort that Nico mentioned at the beginning, so you can truly believe that you are there and you're interacting with this kind of, non-existent virtual content, you really had to try, you really had to push. So for entertainment purposes, it was a bit of a letdown back then. So then it was only used by industry or whatever, by experts that, okay, that's not a notion. Whether you believe that this information or not is there, well, this is something that is directly related to your work, and of course, you are doing it. What Oculus and the other recent companies managed to do is they, first of all, they reduce the weight and the bulk and the kind of all the cables. I mean, still, you don't have it quite wireless. You have some cables because there's an issue with the data that are required to be transferred, but this is very light. I mean, the latest Oculus, the Oculus consumer version, it almost feels as heavy as a bike helmet, and that is truly, I mean, that's much more comfortable compared to other things. Because imagine also that you have to wear this for an hour, 2 hours, 3 hours, and interact in a virtual world. I mean, and you wear something like a motorcycle helmet, kind of, which is much more heavier. I mean, of course, after a while, you're going to be fatigued just because of that. And the other most important thing is that they fixed the issue with the response time. So it's ridiculously responsive, and it doesn't cause these kind of biological and psychological kind of feelings of nausea. I mean, I turn my head, I know my body knows that I turn my head, but the visual input is still there. It's kind of following. So with these kind of devices, you finally have a much more realistic and immersive experience. And this is the thing that they did. Some of them better than others, but I mean, we have an Oculus and it's really working well. We haven't experienced the Vive. That looks promising as well. Yep. Yep.
You said you have wires attached to the Oculus. I have the Samsung. It's completely wired.
Right. Yeah. No. Okay. The Samsung is smaller version, a small branch of that, and it just uses the phone. So everything, all the processing power and everything is within the phone. So that's true. Yes, that is completely wireless. However, if you compare the responsiveness and of course the resolution and how much you can get out of a mobile phone, I think it's a Samsung S3 or S4. S6, yeah. I confuse the numbers. Yeah, but I mean, if you are impressed with that one, I would really recommend you try the proper headset, because that was also an issue when they were developing it, because Oculus was in development, and halfway through they got like the collaboration with Samsung, and Samsung of course pushed like, hey, I want something on the market right now, and it has to sell. VR is hot right now, so let's do it. And there was a lot of internal fight with the engineers that were pushing back and saying, look, I know we can do it. I know we can release a product, but it still has to meet a certain, QA experience, acceptance, that people are not going to be again disappointed. Because as I said, the problem with some of the very early VR systems, I mean, they were working, but they were very slow. I mean, the resolution and everything was a bit low. So, I mean, again, meeting the expectations was a bit hard. So it was very important. And I mean, for a moment there, for all of us who were following all this, it was quite scary to see that because of a business decision, and somebody wanting to push a project in the market, you could jeopardize kind of how VR is perceived again for this cycle. But luckily, and you are an example that, you said that you had a good experience with that. Okay, it has been, accepted by the audience. That's okay. And I mean, now that the commercial version of Oculus is out, also people are excited, because that's important right now. The price is about right, let's say, for what it delivers, and we really need to work on providing the experiences and meaningful apps as well. We need like some killer apps for that, and this is partly from more the academic perspective of what we're trying to do.
How is the
The yeah, so the Samsung, you get the the cupboard. Yeah, it was there. Yeah, so it's basically the encasing, and it has the button on the side, right? You can you can click, and a very similar kind of lo-fi approach is the Google Cardboard, which it's not it's more ecological. So they went away with the plastic, and they just have like the cupboard, and but they still have the lenses. I mean, you have I mean, the lenses are the most expensive bit of that. So that's how much was it?
25 euros.
Yeah, it's 25 euros. Samsung was making the commercial push with that. The Oculus is $700. The Vive is.
I think it's around the same. It was slightly more
I
expensive.
think the Vive. Yeah, I think the the Vive was a little bit more, but the Vive has more sensors as well, because they do like room tracking. And for the PlayStation VR, we don't know the price yet.
I think it's price tag around like 500.
So 500, but I think in terms of responsiveness and whatever, it's not gonna. Okay, my guess is not gonna be as impressive, but anyway. Yeah, so the resolution in Oculus is quite good. I think it's 1080, right? Yeah, it's 1080p finally. No. I mean, for the exactly I mean, yeah, there were two things. What you said, being able to see the pixels and having this anti-aliasing effect everywhere, and the responsiveness of that. Because on top of that, if you could see the pixels, then it was even more. I mean, this was adding to the slow response for the overall thing. And we had people that were putting on. I mean, I've been backing the Kickstarter since the first Kickstarter that they did, and we tried that in the office with some people. Just, hey, we have the new VR, try it out. And out of, I don't know, 10 people, 1 or 2, they had to take the headset immediately. I mean, they were going to be, well, not violently sick, but I mean, yeah, it was like, some people are very sensitive, and that is a kind of a problem with VR, because it seems that almost it is an issue with, I mean, it's a physiological issue. You can't do much about it. So that is the thing. But the commercial version of the Oculus, it is really impressive, and especially seeing the evolution of this, seeing the previous versions from the first prototype, the second one, and now the commercial one. I mean, you can really. Well, that would be because I mean, yeah, sure. It's because actually for the definition, it's not so much like a discrete thing. It's more like a spectrum, kind of a continuum kind of thing. And the more you have elements from real life, for example, then you're approaching a little bit towards augmented reality. So I would say an example of the 360-degree videos, they're kind of halfway to virtual reality to augmented reality. Because, for example, no, but yeah, yeah. Yeah, you mean if it's static, if it's pre-recorded or live? Yeah, if it's pre-recorded. Yeah, so I mean for the pre-recorded, yeah, then I would argue it's then that shifts it a little bit more towards VR than AR. But again, you could have it live. No, but I mean you could. No. Yeah, I know, but you could also have that. You could have like a live feed from that. We have a what's it called, like a Theta camera?
I have one here.
Yeah.
If you just have a look at this one. Here.
Yeah, or maybe show it to the audience. I mean, I've seen. Yeah.
Can you see it?
Yeah.
Turning torso, yes. And they are very easy to use. It makes marvelous videos.
Yeah. And we have been playing with the Theta.
Rico Theta.
Yeah.
That's quite
Which is very, very impressive because now the latest one is again 1080. Yeah. The,
We have some people who created an underwater game, like a
Mhm.
game. Like when the movement was easy, you just got so disoriented that the nausea came on pretty quickly. If they tried to even it out, the controls became much more difficult. So they ended up having to choose between either having easy controls and people getting more nauseated or
yeah.
and then that's a harder time actually getting around in the game, but at the same time, people be able to play it longer. And I think it's kind of like the easy because it's the horizon issue. If you're able to like dive
Yep.
any direction, it's just like oh, I need to take this off before I.
Exactly. There's this, for example, for the stuff that Nico did, we've been playing around with a concept called Swivel Chair VR, which you assume, because of the scenario, that you are sitting in a chair. What you are presented with, and the looking around, so you can look around. I mean, you can turn around as you would, in a chair. So this is natural. But I mean, the separation from what you feel and what you visually perceive is not so great. So that is okay. Now, if you have to walk around, or if you have to have controls, I mean, if you to walk around, that increases the notions of nausea, as you said. So some people, for example, are experimenting with not letting the user just walk around. You have like these teleporting things. We're doing I mean, you're going to see later, we're doing a traverse thing. So you choose a destination and you are moved. You are not moving. You are moved there, but slowly, kind of thing. So it's understood. I've seen some examples that, some experimental settings where when the user needs to move, they have to actually sit down. So when the system sees them kind of kneel down, then that's the signal for them to move. And the point for this is that because you're moving and you're having these disoriented signals, still your body feels much more comfortable. Instead of like I'm standing up and now I'm moving, I'm having like this notion. But if I'm there, it's slightly a bit more comfortable. I haven't tried it myself. I mean, there's a lot of things to be experienced. But some people still, because we have some people in our group in our university, they are very sensitive no matter what. Yeah. No, that is. Exactly. Yeah, I mean, we have solved kind of the how to get the environment outputted to you, but like the input, like the controls for all of that, we're not quite there. I mean, in terms of something that feels really natural. Of course, you can do a lot of things. You can like really scan and track kind of your hands, whatever, and then use that as signals. But it's still, depending on the scenarios, basically. But we're going to show you some, some examples.
Yeah. Also, to add to that, it also depends on the game design. So because I mean, lots of games that are developed now, so you don't necessarily have like you have the first person view. So, but from the game perspective, it's like you are sitting in a cockpit. So you have some very static like surroundings. So that also help you. Going against that feeling of nausea. So because simply you have like this, still you are like in virtual reality. So but you still have like these static anchors of your cockpit or whatsoever like in front of you that help you towards it.
The issue was also that they made so you could move at a maximum of 45-degree angle, which
Yeah.
dealt with the nausea, but on the other hand, if you're in a submarine, it makes it way harder to
Yeah.
get around, like, because they had the test, like, for example, trying to get through hoops, circles on the
Yeah.
water,
Mhm.
and when they turned the maximum 45-degree function on, it was super easy. So it was interesting to see that the less than the nausea was at the cost of that
Yeah.
game experience.
Yeah.
There's always a trade-off, and I mean, this is still very open in terms of like the design, and it really depends on the scenario.
Yeah, that's also like why it's like a really interesting time. So because all of these kind of like problems that we thought were like solved, I mean, have to be like simply like redesigned for VR. So because it's a completely different experience than just watching like on a projector or on a comparatively small 2D screen, right?
And in a way, just one final comment. Some of these problems you would think, because VR was around for a long time, and you would think that some of these problems were solved already. But in a way, because the technology has improved so much, and the response has improved, and the fidelity has improved so much, because of the low fidelity and the low response of previous technologies, some of these issues were not there, or you were handling them just. I mean, the technology was not allowing for that, and therefore you could get away with it. And now you can do more things in a way, but with being able to do more things and provide kind of much more higher fidelity, you have the problem that you have to solve these issues that were just hiding there. So the more responsive the system is, then you have this. So it's interesting.
Yeah. Yeah, Aris already talked a little bit about like the Google Cardboard, which is like a very cheap VR demo approach. I mean, we usually use it, for example, at exhibitions or things like that, because I mean, you just use like your smartphone, then you have like this cardboard box with the two lenses in it, so and it's like very easy to just demo the concept of VR. So, and then talking about a few like use cases. There was like one project that took the aim of recreating real-world existing museums. So, but completely digitally with common computer graphics for the usage of or within VR. So that technically everyone from around the world could, for example, go to the Louvre or visit the Louvre without actually going to Paris, for example. So then there are also some cross media or more like game design approaches. There is an adventure game called Kentucky Route Zero. So and the developers released like a supplemental app which is called like the Entertainment. So and the idea of that is you are within a virtual reality environment. You are sitting kind of like on a stage. Here, like in front, is like a bar with a bartender and like a customer, and they are playing this like very famous piece called The Entertainment. So, and you can like look around 360 degrees. So, and if you focus your view on the bartender and on the customer, so the scene would kind of like continue playing. So, but if you would focus your view towards like other game aspects, so that aspect technically like would pause. So, and you could like focus on other elements within the scene. So, for example, there was also within the scene there was a jukebox. So, and if you would look and center your view onto the jukebox, so you would hear the soundtrack of the game, for example. So, and if you would look around, so you could actually see the audience. And you would get some developer commentaries, for example, and things like that. So, I mean, there's like lots of interesting things going on also in that direction. So then we have, I think for the Samsung Gear VR, it should be available, this Netflix player. So you can actually watch Netflix within like your virtual reality headset. So instead of like, okay, watching it like on a TV or something, so you sit in your virtual living room, so to say, and you have access to all your Netflix like library. So now this is very interesting because it's like completely single player or single person experience, so to say. So but now if you imagine like in the future, for example, you have you could go into a cinema with your friends that are also using a Gear VR, so but they are sitting physically like around the world, for example, right? So you could actually meet within a VR space and watch like a movie together. So just like conceptually. So I mean that is towards where we are pushing eventually.
How do you notice that you are together?
Yeah. That would be ultimately the goal, that you can like see each other, so and of course like also like speak to each other, right? So no. Yeah, I mean the representation of yourself within VR, I mean that is simply like still a problem that needs to be like figured out how to do that. If you represent yourself through a simplistic like avatar or like a very realistic photo model of yourself or something like that, so I mean there's certainly like room for improvement and room for experimentation on how to solve that. So then we have also some educational purposes that VR can be used for. There's an application called Titans of Space. So and the idea is like you are sitting in this space, like a Rymdkapsel. And you are floating around within our solar system. So and you get like a very good impression of how big the planets and the suns and the moons of our solar system actually like are. So and then you are also presented with some textual information, so you can actually like learn again, like experience the solar system as you were there. So and also like learn a little bit about it. Yeah, well, I mean that's like up to your imagination, right? So, but at least I mean, if graphics like become more like realistic and everything, I mean, it could be. Feel like you are there, right? Like, yeah. So, but I mean, that's also like the power of VR, right? So, because I mean, we are not just using VR to replicate real-world problems. So, but also, I mean, to play around with gravity, for example, right? So, or with other concepts that we are so in reality kind of like limited to. So, that's very exciting. So there was another interesting project by Simon de Diesbach called Occult Us. So and he basically made like this experiment of being presented with a virtual reality environment. So he would move you throughout like a corridor. So and all the sounds of that virtual reality scene were actually like not digitally produced, but analog, using, for example, scattering glass or certain other like physical devices. So the system was like totally in sync. So you had like this analog audio sources combined with the virtual representation of the scene. So we also have, I mean, in the end, if we have some time left, and we also have some videos, so we can show you a little bit more about that. So then there's also actually by Oculus themselves, they within their company they founded like a division called Story Studio. So and Oculus Story Studio is actually particularly investigating movie experiences within VR. So they are like really interested in how to do storytelling within VR. So because that also VR in a way changes how you perceive and how you do movies, right? So because right now so far, I mean, we have like a 2D screen, so and the director can focus your view very particular on like certain events within the scene. So the director can make sure that you will see what the director intends you to see. So, but within VR, when you can like look around 360 degrees, so I mean, maybe you focus on something like completely different that the director don't want you to see, or maybe there are multiple things happening at the same time. So therefore, also storytelling and movie making has to be like reinvented technically from scratch. So and I think therefore, I mean, for Henry, we have actually like a movie. Let me see. Now what do I want? Do we have sound? Oh yeah, okay. Perfect.
When I think back on the movies I love, I remember the characters much stronger than I remember what exactly happened in the story. I wanted to live that adventure again with them. Now with VR for the first time, you can actually be with that character.
Virtual reality is one of the few technologies where you can make characters that are so much more compelling than is ever possible. In film, it's all frozen in time. In virtual reality, the actor is alive in every moment.
Just imagine if you're in a movie and the character would suddenly look at you. Henry will do that. Henry will be aware that you're there watching the story unfold.
Henry is a short movie about Henry the Hedgehog and his adventures to find friends.
I like seeing people's faces light up when they put on the headset for the first time. But I wanted to be in the same room with some of the characters I love working on, and I want to feel that empathy with the character.
Empathy in VR is the most important field that we need to explore.
Our empathy for him will increase so much more because Henry is right next to you. We will be more surprised by the story because it doesn't feel scripted.
The bar in virtual reality is high for making a character feel like they're actually in the same space, not a pre-recorded character in a game or a pre-recorded actress doing bit making in some movie. Henry now performs as if he's real, and you question yourself, is Henry doing that because I'm here?
This sense of presence, being there, where you see somebody, maybe it's a character in a story, that turns and connects with you. Those spark emotion that you can only get in VR.
When we grow up, we kind of forget that as kids, these characters in the films we watch, they're alive. And with VR, it makes me feel again like I'm a kid because I can see this character is real.
All of a sudden I have this hedgehog alive in front of me, looking at me, blinking, breathing. I felt for him. I had to care for him.
People will love Henry. It's not that you're sitting in a theater watching it on the screen. You're in it. I mean, there's nothing more exciting than that.
They have made a number of interactive experiences like this to showcase the headset. But what I'd like to point your attention to, as you saw, when people were interacting with this, they were waving at the character. Or I mean, of course, you have like the point of view that you're trying to look closer, but a lot of them were doing things naturally and consciously that, of course, the system has no way of interpreting, right? So there is no kind of, but I mean, as humans, I mean, the feel to communicate, gesture, emote, kind of thing is very natural. So again, it's this thing about the input, how much the system knows from you. I mean, besides like the control of the character, but also how you interact with the other elements of the scene.
Yeah, so and then there's also the system that kind of like you were talking about. So it's called Joint VR. So and the idea is they have like this camera rig. So it's not just like one lens anymore. So but they have actually like lots of cameras to create like the 360-degree like live view. So and then yeah, be basically like on stage with Paul McCartney, for example, at his like next concert or something like that. So and there are demos by them like out there that you can like actually try with the Gear VR or with the Oculus if you have something like that. So again, so we are not just talking about completely virtual generated kind of like content, so but also about like real world 360-degree footage. So and of course VR can also be used to explore more geological data, for example. So what they did here within this concept was they had like this cave. So and they were scanning, 3D scanning the whole cave. So and afterwards recreating the scan with the textures and the photo material that they shot on site and within the Unreal Engine. So and then they were able to like, okay, go back into the cave from like their home offices, so to say, and further explore that cave. So VR can also be used within these kinds of application cases. So yeah, so now we're going to talk a little bit about what we have been up doing. Yeah. So far for the introduction. So yeah, in the center of everything is of course virtual reality using the head-mounted display. So because that is particularly for the vision, for the visual layer of how you experience and the content, technically. So, but still, using these head-mounted displays, we haven't solved how we actually interact with the data, right? So, because using the glasses, we only can technically like look around. So, therefore, we have to think about like, okay, how do we actually interact within that scene? So, using either game controllers or, I mean, keyboard and mouse are rather like counterintuitive. So, because they are like designed for 2D displays, actually. So, and since you're also wearing like the head-mounted display, so you can't see your physical surroundings anymore. So therefore, going back to computer and mouse, for example, is like very counterintuitive when being in VR. So, and I mean, then of course we also have like talked about immersion, so the overall interaction, open data, and data visualization. So, and yeah, if we go back and if we look on like how we actually interacted with data so far, back in, yeah, I think 2007 was when the first iPhone was released. So we actually started touching data in a way, so, right? So we are able to yeah, interact with digital information in a much more natural way, not by using like keyboard and mouse, which are like these kind of like pointer tools that have been developed, yeah, in the first place. So, but now we are actually able to, okay, drag around information, touch information in a way. So, and so, but that's for the interaction part of view or point of view. So, but if it comes to the point where how we perceive information, right? So, I mean, as a human being, right? So we simply like we look around. That's the most natural thing that we do in order to, like, yeah, perceive our environment, perceive information. So, and virtual reality now has like the possibility to also bring this kind of natural behavior, yeah, make it available to experience digital information more naturally, right? So we have, on the one hand, like this very natural touching around for information, and on the other hand, we also have now a possibility to experience the visual layer of the information very naturally. So, and there are technologies out there, like, for example, the Leap Motion controller here, or I'm pretty sure you've heard about the Microsoft Kinect, which is a very famous or very common motion detection controller, so to say. So it's a depth camera. So, and the interesting thing about the Kinect is, and the Leap Motion controller, is that they, without the need to wear additional sensors on your body, so they are able to recognize your movement, right? So, I mean, the Kinect can basically track your whole body movement. So, and the Leap Motion controller is able to very precisely translate your hand movement into digital information and then represent it in the virtual space also accordingly. So, and for our research, it was like particularly interesting on how we interact with data, right? So we have like lots of open data sources out there, like Wikipedia or Twitter or all kinds of other data that has also been made available by the government. So, and we thought like, okay, what will actually happen, or how could we design like an interface that brings together like open data, visualize it in the virtual reality environment, and then also make it somehow like interactable. right? So and yeah, so basically what we did was we had a look at European capital cities from Wikipedia as our like open data source. So and then what we were doing was we were creating a network of the cities based on a map of actually like Europe. We present all these maps or all these cities as nodes on this map. So and then using the Oculus Rift, so you could travel from node to node and using like your hand gestures with the attached leap motion controller in front of the Oculus display, you could kind of like do certain gestures in order to get like an interface and get some information about the cities that you are currently in. So and yeah, I think we'll show a video so you get some kind of like impression of what's happening. Oh, jump. Yeah, so here you can see the user and wearing the head-mounted display. Here you see what I'm seeing within that virtual environment. So and using the leap motion controller, so you are actually able to translate your hand movement into the environment. So you don't need like a controller or like keyboard and mouse or other kind of interfaces to fiddle around with. Because also, I mean, as you're noticing, I mean, now I'm not able to see my surroundings anymore, as I was telling you before. So and here we have like a certain like gesture set. So right now I think we were in Vector. So and using certain kind of like swipe gestures, I'm able to like trigger information about vectors that were originated from the Wikipedia, right? So and now, for example, I was looking to I think it was Copenhagen. So looking there, doing like a small push gesture, and there we have like this transitional like movement. So I'm not able. We decided to make the user not able to walk freely around on that map. So but use these kind of like small like gestures, and then have like this transitional movement, for example, right? So and with the users that we tested, that was very successful, I would say. So I mean, we didn't have like lots of. I mean, I don't think we had like any case of nausea. So I mean, that was certainly the right decision there to have like these short, slow traversal like movements. So and as you can also see, for each kind of like recognized interaction, we have some visual feedback to notify the user that hey, okay, your gesture got recognized. Yeah. Start again. Right, yeah. So, so on the one hand, we have like this using these gestures, these swipe gestures. We have like an invisible interface, so to say. So the user has to learn like, okay, which gestures are actually like around, and when can I apply one, right? So we have like this swipe gesture to get the content, swipe gesture to like pull away the content. Then if I'm looking to like a certain node, so I make like a swipe gesture to the front, so that indicating that, okay, now I want to move there, right? So we have a certain set of, a simple set of gestures. So, and on top of that, we were also interested in how to display a graphical user interface within the 3D space. So I think in a few seconds, so you will be presented with a graphical user interface. So with actually like certain like filter options. So then I could say like, okay, for example, now I'm in Copenhagen, and now I only want to be connected to cities that have a higher area, that are bigger than Copenhagen, for example, right? So then I could push the button, so and visually I would be kind of like connected to these nodes as well. So and also I wouldn't be allowed to walk to nodes that are that have a smaller area, that don't apply to the filter option that I selected. So there were, within this prototype, there were actually like lots of things that we were kind of like interested in investigating. So these, as I said, like this swipe gesture set, the interaction with the 3D. Also what was like very interesting was, I think you could see it here for a second. So now in Berlin, for example, and I have like an image like on a plane. So and I could swipe it, get like another image, so and then get the first image again. So we also had a prototype version where we had a set of like several more images. So, but the users would say, for example, that felt like very unnatural. So because it almost feels like a sheet of paper, so they are able to like look what's on the front, swipe it around, look what's on the back. So once they swipe it again, they would expect what the content of the front page again, right? So having like more content, for example, would actually surprise them and say like, hey, okay, that didn't feel natural in a way. I mean, the swiping itself felt natural. So, but since there was like content that they didn't expect in the first place, that felt, yeah, very unnatural.
So to talk, and again, this Swivel Chair VR that I was talking about, all the users, they're sitting down in a swivel chair, they're able to look around, they are able to rotate, but I mean, they don't, I mean, again, for the transitional movements, it feels okay for them. I mean, as you can see, okay, all of them started pointing at the desk, but at some point, depending on where they are in the network, they might be pointing completely different and doing the gestures, and that's fine. And they feel safe and kind of without many problems. So, but the just to talk about the overall scenario and the kind of more high-level idea here. So the idea is that you have a repository of open data, and you create a network out of that. In that case, we chose to make it easier for ourselves because we said, okay, Europe, capital cities, okay, represent them in a network. Okay, you can borrow actually the real topology and geography of Europe, so you can put them as they are in reality. You could have a network of any other data and nodes in any other configurations. That was just convenient here. Each one of the nodes has some information specific about the cities, and then we picked two properties: the size, the population size of the city, and also the area of the city. Because when we wanted to test this with the users, what was the actual tasks that we gave to these participants? We didn't want to do the classical kind of, do you like VR? Do you feel immersed? You know, all that, of course, because there's a novelty effect. Everybody would be just excited. I mean, they were excited. They liked it. Nobody had nausea, but that wouldn't tell us much about whether they would be able to do something meaningful. Although, I mean, the tasks are kind of trivial, but still, to do like a meaningful task. And then the task that we gave them is try to find, they all started from Vecchio as the starting node, but then we gave them two tasks, and it was like, try to find a city with an area close to this number, or with a population close to this number. That was a bit of a tricky, and that wasn't like find the biggest city in Europe, for example, because that would be easy. Everybody would go to Moscow initially. They didn't actually have to use the system, right? They didn't have to explore anything. So we wanted to make sure that we give them a task that they actually had to visit nodes. They had to check the information there, and they had to make some decisions based on how they were offered this information. So we told them, okay, here's a number for the population, and here's a number for the area of the city. Try to find those that you find that you think is close enough. That was a trick task in a sense that there was no city or that had exactly that number for the population or that area. So they had to be close enough. So because we wanted them to explore, we want them like to look around. And actually, do you have, oh no, you don't have the slide with the results. No, okay. But of course we had like candidates because we gave them a number, for example, between two possible, we had like 4 possible solutions for each one of these tasks. And all of them, I think only
within the first task, there were 2 that were like slightly off.
Yeah.
So,
but they hit the point. So the point was that they were able to do this random walk exploration, kind of retain data, kind of make an informed decision. They didn't have to actually be at the city. I mean, for example, they could do like a walk. Actually, if you go down to the paths, at the very end, just jump to any of the, or the very last one. We have compare the, yeah. So they didn't have to be at exactly the node to say like, okay, this is the node. They could decide, oh yeah, okay, I've been in Berlin before, and I think Berlin is the solution for this task. And we saw like different behaviors in the sense that there were some people that did went around a bit in the loops because they needed to like reconfirm or check again because they didn't remember. And some other people that just went on a straight line. And at some point they said, hey, you know, I visited 20 cities or whatever. And based on that, yeah, I think, you know, the one that I visited 5 cities before was the solution. And they were still fine. Kind of. So, I mean, at some point, of course, the user kind of gives up or says, okay, I've explored enough. But luckily enough, they were within the expected kind of parameters. So that was actually kind of nice.